Yes, sir. So we know that electricity is the flow of electrons, right?
Electric,
Negative charge.
yeah, electricity is basically definition is flow of the charge, but it's mainly because of the movement of electron. That's true.
Yes. So why do we like base the electric field in this direction on the movement of the positive charge?
Because what happened, the in the early 19th century, most of these laws which are related to electricity, so they assume that actually the movement is of positive charge. That was assumption, and most of these laws of electricity, they derived on this assumption that electricity is actually a movement of a positive charge. But later they found that it's not movement of the positive charge, it is actually the movement of electron, that is the electric current. But instead of changing all the laws, they just assume or use that same assumption till now, that actually the electric field is a force experienced by the test positive charge. Otherwise, what they have to do, they have to reverse the sign of all these laws which are related to electricity. So instead of changing the sign for all these laws, they just still consider this, that the electricity is a movement of positive charge, and the electric field is a direction of the direction of electric field is same as the direction in which the positive charge will move. Is it clear?
Yes, sir.
So
Clear. Yes.
actually, it's not in reality does not happen, but because the laws were are based on the assumption, that is why still they continue this assumption. So if a question is,
Yes, sir.
so electric field, it is a region around a charge where the four where other charges can experience force, the direction of electric field is same as direction of force experienced by test or a small positive charge. So if the question is draw the electric field lines, if I say draw electric field line for proton or positive charge. So if you want to draw electric field line for a proton or a positive charge, so proton itself is a positive. So example, if this is a proton, I want to draw the electric field lines. So which direction these field lines should point? These field lines should point outward. Why outward? Because if I place a positive charge near this proton, that positive charge will move away. If I say draw electric field line for charged sphere, so for a positive charged sphere, because the charged sphere will have more charge, so it will have a stronger electric field as compared to that of a proton. So how I can distinguish whether a field is stronger or a weaker? So to show this, I will draw more field lines. And if I place a positive charge, that positive charge will always move away from this sphere. The pattern is same, but how to show the strengths are different? What I will do, I will draw more field lines. So increasing the number of field lines, actually what it shows that it is stronger. Is it clear? So the difference is the strength is different, but the direction in which the positive charge move when it is placed next to a proton, or a positive charge move when it is placed closer to a positive charge sphere, that will be same. If I want to draw electric field line for electron or negative charge, so for electron or negative charge, electron itself is a negative charge. So how we draw this? If I place a test positive charge, it will move towards this electron. So as it move towards the electron, the direction of the field or these field lines should point inwards. And if I want to draw for electric field line for negative charge sphere, so for a negative charge sphere, how we represent? The negative charge sphere, more negative charge, it means it will have a greater strength. So how we distinguish? The arrows will point inward, but to show that they have different strength, so we will draw more field lines. Is it clear? So for positive, the electric field lines are pointing out. For negative, the field lines are pointing in. Then they can also ask, draw electric field for capacitor. Capacitor means like two metal plates are placed together. Parallel plates or capacitor or electrode. So if two parallel plates are there, like this is one, this was another, and we have a positive and the negative charge on these plates. This is also known as capacitor, electrode, or parallel plates. So electric field lines, it should be straight line from positive to negative, parallel lines from positive to negative, and equally spaced as well. Like I should draw equally spaced, same distance between the lines, because it is constant electric field. And near the edge, around the edge, it will be a slightly curve. This is how we draw the electric field lines. These are the cases which you will find. for a test positive charge or a charge sphere, a test negative charge or electron or a charge sphere, parallel plate. This is the third one. Then if two unlike charges are there, so electric field between the unlike charges. Unlike charges means like one is positive, another one is negative. So one of them is a positively charged, another one is negative. So when you draw the electric field line for, in this case, it is out from positive and into negative. So between them, there will be a straight line. And the rest, it's from positive to negative. So you have to practice these patterns. For negative, it is pointing in, and for positive, it is pointing out. And electric field lines between the like charges, if identical or the like charges are there, as we know, like charges repel each other. So positive and positive, or negative. So as they try to cancel out each other, they try to cancel out the electric fields of each other. So what it appear, how we represent a pattern of electric field when they try to cancel out the effect of each other. So between them, there is no field lines. Why there are no field lines? Because there is no electric field. They cancel out the effect of each other, so there is no electric field. That is why I did not draw any field lines. And because both are positive charge, so for positive charge, the arrow should point outwards. If I want to draw for negative, the two negative charges, they will also repel each other. But the only difference here is the arrow. For negative charges, the same pattern. Between them, do not draw any field lines. The pattern will be same. And the arrows should point inward. Is it clear, the concept of electric field? So you have to practice these patterns, like you have to learn how to sketch electric field for a positive charge or a charge, positive charge sphere, a negative charge or a negative charge sphere, between electrodes or capacitor, and then electric field lines between the charged plates, as well as unlike charges and like charges. Like charges, it can be two identical positive or it can be two negative. Any question related to this? Yes, Mohsen. Tasif, you have a question?
Sir, sorry, I forgot my hand raised.
Okay. Yes, Tasif, you have a question? Okay. Okay, some question now related to electrostatics. Already we discussed. What's the answer for question 1? MCQs, multiple choice question. What is electric field? I want participation from everyone. So, yeah, B is the right answer. What about the first one? A region around a wire, that is actually magnetic field that we'll discuss. So, but electric field is a region where electrical charges can experience force. In question 2, a negative charge rod is held close to one side of a metal sphere. The other side of a sphere is Earth. Which diagram shows the distribution of the charge on the metal sphere? Look, keep in mind it is Earth. So if it was not Earth, then B was the right answer. But as they mentioned, like example, if this one was not Earth, Earthing was not connected to this, then B was the right one. But they already mentioned it is Earth. So what earthing will do? Earthing will allow what earthing will do? Earthing will allow the electron. First, it create a distribution, but negative charges experience the repulsion from the charge rod. So these negative charges will go out. So majority of, as the negative charges will go out, most of them will be positive. That is why D is the right answer. Is it clear why D is the right answer? Because why A cannot be an answer? Because the negative charges will not remain in the sphere, they will move out from the sphere. Question 3. Student rubs a plastic rod with a cloth, the rod becomes positively charged. So why the rod become positively charged? Because it lost electrons. That's why C is the right answer. Question 4. Which quantity is measured in coulombs? A unit of the charge is coulomb. That's why A is the right answer. Question 5. A polythene rod is rubbed with a cloth. The rod becomes positively charged because the movement of a charged particle. Which row gives the name of these charged particle and the direction in which they move? A rod becomes positively charged. Yeah, that's right. B is the correct answer because the rod become positively, so it should lose electron. So electron actually travel from rod to the cloth. Question 6. There is a current in a metal wire. Which particle in the wire move to cause this current? Protons, where they're present inside the nucleus, they're not existing as a free particle. That's why it's not proton, it is electron. Neutron cannot be an answer. Alpha means 2 proton and 2 neutron. That is in block 5. You will study about alpha particles. So B was the right answer because it's electron. The diagram represents two different electric fields. A single electron is located in each field. Like we place an electron here and we place an electron. Which row give the direction of the force on electron and the field in which there is a large force. Direction of the force means direction in which the electron move. Keep in mind electron is a negative charge, so negative charges will always move opposite to direction of electric field. And which field is stronger? Let's write A is the correct answer. The electron will move downward in both fields, but in field 1 it will experience stronger force as compared to field 2. Structure questions related to electrostatic. In figure 8.1, S is a metal sphere standing on insulating base. R is negatively charged rod placed to S. Name the particle in S that moves when the R is brought closer to S. So which particle will move in this sphere S? Electrons, because this is a metal sphere. Metal sphere, what it contain? It contain a lattice of a positive ion and the delocalized electrons. So positive ions cannot move at all. Actually, what happened? Like if this was a positive ion, positive ions cannot move because of their size and they have a regular positions. But what it causes when we bring a negative charge rod, so it causes a distribution that electron, delocalized electron, shifted towards one side. So what it create? It create majority of the positive on the left and majority of the negative on the right hand side. So name the particle which will move, that is the electrons. Keep in mind the positive ions and positive charges cannot move because of their size and they are at fixed position in a lattice. On the figure, add a positive and negative sign. So left hand side will be positive and right hand side will be negative. But keep in mind, draw the equal number of positive and negative charges. If you draw like 4 positive and 3 negative, then you will lose the mark. Because overall metal is neutral, only the charge rod will create a distribution. Then describe the action which now needed to make to place so that S become positively charged. A positive charge object is not available. So we want to make a positive charge. How we can make it positive charge? So what we will do? This is first a distribution. If I want to make it permanently positive charge, so I will connect an earthing wire. So one mark is for mentioning connect an earthing wire, which will remove, because it's of 3 marks. So what is the first mark? It's connect earthing wire, which allow negative charge or electrons to move out. Which will make it net positive. So the net positive charge is there. Then how we will make it permanent? Then we should remove the earthing wire and then the charge rod. Now you don't have to draw equal amount of charges. Like it's not like here you can see in a rod 1, 2, 3, 4, 5, 6 are there. So here you don't have to draw 6 charges. That is not the case. But the number of the charges which you draw on the sphere should be equal. Then remove the earthing wire and then the charge rod to make it permanently positive. Is it clear? The third part of this discussion. Figure 8.1 shows a high voltage supply connected across the two metal plates. So these are the two metal plates. I told how to draw the electric field lines for the metal plates. As you can see, if you have a capacitor or a metal plates or electrode, this is how we draw the field line. So the question is similar to that, that you have a high voltage supply which is connected to the metal plates. When a supply is switched on, electric field is present between the plate. What is meant by electric field? It's of 2 marks. So you have to write the standard definition. It's better you learn this definition. So force experience the region around the charge where a small positive charge can experience force. That is known as electric field. Then on the figure 8.1, draw the electric field lines and indicate the direction by arrow. So how to draw the electric field lines? Because electric field is from positive. So you can see this plate is connected to a positive terminal. So this is a positive plate. And this one is a negative plate. So electric field lines are always from positive plate to negative. One thing, you should draw uniform. Uniform means like it should have a uniform equal spacing. If you draw like this, you will lose the mark. So it should have a uniform spacing. Even spacing should be there between the lines. And near the edges, it will be a curve. In figure 9.1, A and B are two conductor on insulating stand. Both A and B initially uncharged. So here they're uncharged, not charged. Conductor A is given the positive charge as shown in figure 9.1. On figure 9.1, mark the sign of a charge induced at X and induced at Y. So of conductor B, what will be the charge on X? On X, the side X, what will be the charge? So it will be negative. And what will the charge on Y? It will be positive. Now explain how these charges are induced, like how these charges are produced. So basically, like charges repel, unlike charges attract. Which cause movement of the positive charge sphere A, cause movement of electrons which towards left, which make net or which make a majority negative charges. So you have to mention the law of electrostatic and then no, the like charges are repelling and unlike charges are attracting. The positive charge sphere. What this positive charge sphere? It will cause the movement of electrons. It will attract the electron. The positive charges experience the repulsion, but they are not able to move because of the size and because of their structure. They are in a lattice, a regular arrangement, so they are not able to move in the lattice due to this force, but they experience the repulsion. Sorry, okay, you mean this one. That's by a typing mistake here. Like charges repel and unlike charges will attract. Then explain why the charge at x and y are equal in magnitude. So you, because why they're equal in magnitude, like if I draw 3 negative or 4 negative, I should draw 4 positive. Because what is the reason? Because overall the metal contain equal number of positive ion and free electrons or delocalized electron. That's why the charges, the positive and number of the positive and negative charges will be equal in magnitude. Magnitude means number. B is now connected to Earth by the length of wire. State what happened if anything to X and what happened to anything to charge at Y. So basically we connect an earthing wire, what it will do, it will allow the charges to flow. So as you can see, when it create a distribution, so we were having a negative charge on one side and positive charges on either side. And we can, and it is not necessary that always I connect earthing from this side. I can connect earthing wire from any side, it will have a same effect. Like I can connect from here, I can connect from this side, it will have the same effect. Now what will happen as we connect an earthing wire? No, it will not become neutral. What earthing wire will, because the positive charge here and the positive charge here, what they will do, they will attract electron from the earthing wire. So as they attract electron from the earthing wire, now majority of them are negative charges. So electrons will flow into the sphere and majority of them are negative charges. So it will become net or resultant negative charge. So what happened? The question is, what happened to X when we connect an earthing wire? Nothing happened to X. So at X, nothing happened before also. Before connecting the earthing, it was negative. After connecting earthing is also negative. But what happened to Y? The Y, the region, the Y, it will become neutral for that part. Why it will become neutral for that part? Because equal number of positive and negative charges now. So the side Y will become neutral. But when we replace this, when we remove the earthing wire and then the charge rod, so overall it will be negative. Is it clear? Because the question is, state what happened after connecting an earthing wire, what happened at X. So at X, nothing will happen. But what happened at Y? At Y, the positive charges are neutralized by the negative charges or electron. So if we bring a positive charge rod, so negative charges one side, positive charge other side. So at X we have positive and at Y, at X we have negative and at Y we have positive. Now I connect an earthing wire, like I connect an earthing wire here. So what happened? The positive charge at this point and the positive charges attracting the electrons. So electrons will come up and these electrons will neutralize these positive charges. So when these electrons neutralize these positive charges at x, before earthing or after earthing, it remain negative. But at y, because the positive charges are being neutralized by the electron, so the net charge at y will be 0. Is it clear?
But sir, isn't the wire closer to X?
The
So
wire is
like
close. Electron will experience repulsion, but overall they have more attraction than repulsion. That's why it causes the movement of electron.
so regardless of wherever I just insert the earthing wire, the
Yeah,
at Y it will be neutral. Like
yeah,
more electrons will be present overall in the sphere,
yes.
right? Okay,
So
sir. Thank you.
when it you create a distribution, so positive and negative charges, when you connect an earthing wire, so you can see there's a positive charge at y and there's a positive charge sphere. So more attraction that cause the electrons to move in the sphere. Is it clear?
Yes, sir. Clear.
Yes, Mohsen. Any question? Yes, Mohsen, you have
Sir,
a
in
yes.
this sphere, so we have the positive charge is just lack of electrons, right? So it's not like it's charge itself, like a proton or something.
No, it's not. It's not a proton. It means it because what happened? This is an atom, which is having originally an atom is there. Atom is having equal number of proton and electron. But if this one of the electron or two electrons are being lost, so this will have more protons than electron. That's why the net positive charge is there. So this is not proton. It is actually an ion, a positive ion, which is having more protons than electrons. And due to this size and the lattice, it is not able to move easily.
Yes, sir.
Is it clear, the electrostatics? Um, After 10 minutes, I'll share another such link, 10 minutes break, and I'll just give introduction for of electric current.